In this video, we're going to discuss cardiac output. And we're going to start with defining what cardiac output is. We're going to abbreviate it as CO. And we're going to say the cardiac output equals heart rate times stroke volume. So let's try to unpack what this all really means. We've talked about heart rate before, and we know the heart rate is expressed in beats per minute, which means how many contractions of a heart do we have every minute, where stroke volume is the amount of blood that's ejected by ventricles in one contraction or one beat. So that would be measured in milliliters per beat. And if we are to multiply how much blood we eject in one contraction, one beat, by how often we contract per minute, we would get a total amount of blood that the heart ejects or pumps out in 1 minute. And that's what cardiac output is. So volume of blood ejected by the heart in 1 minute. We're going to measure cardiac output in milliliters, right? So if we multiply beats per minute with milliliters per beats, beats are canceling out, and what we have is milliliters per minute. Okay. So if we assume that on average our heart rate is about 70 and our stroke volume is about 70, then our cardiac output is going to be 4,900 milliliters, which is expressed in liters, 4.9 liters. Anytime heart rate and stroke volume change, cardiac output is going to change. So let's say if our heart rate is 100 beats per minute and our stroke volume is 55, then our cardiac output is going to be 5,500 milliliters, which is 5.5 liters. So if we have the values for heart rate and stroke volume, we can calculate cardiac output. And the question is, what if we have a value for cardiac output and heart rate? Would we be able to calculate stroke volume? And based on this equation, we would be able to, because stroke volume would equal cardiac output divided by heart rate. So if we assume that cardiac output, let's say, is 5,500 milliliters, and our heart rate is 100, so we divide 5,500 milliliters by 100, and we would get 55, and that would be our stroke volume. Also, if we have a value for cardiac output and stroke volume, we can figure out the heart rate, because based on the same relationship above, heart rate equals cardiac output divided by stroke volume. So again, assuming that our cardiac output, let's say, is 5,110, and our stroke volume is 73, then our heart rate is going to be 70. So the relationship between cardiac output, heart rate, and stroke volume tells us that whenever heart rate changes, cardiac output is going to change. When stroke volume changes, cardiac output is going to change. And this change is going to depend on, are we increasing any of these values, or are we decreasing them? So for example, if heart rate goes up, then cardiac output is going to go up. If heart rate goes down, cardiac output is going to go down. Same thing with stroke volume. If stroke volume goes up, cardiac output is going to go up. And if stroke volume goes down, cardiac output is going to go down. In the next video, we're going to discuss factors that are going to affect heart rate and stroke volume.